We'll now add the ability to spawn the navigation map widget when the user presses both triggers on their motion controllers and allow them to resize the map and close it when it is no longer needed. For us to be able to do this, we will need to create a new 3D map widget that will contain the map and related logic. We will build several functions in our VRPON to spawn and manipulate the map with our motion controllers using transform data that we will receive from some simple equations. One being the 3D location of the midpoint between our two hands to place the map, and the other being the distance between our two hands to determine the offset and validity of the map. This will all make more sense shortly. Let's start with a quick function override in our GM Studio Showcase to make testing logic in VR much easier. Override the function getDefaultPawn class for controller and connect a select class node to the return value. And if the return value from a getHMDWarnState node equals warn, spawn the VR pawn, and if not, spawn the PC pawn. We spoke about this when creating the VR pawn, but the reason we need to do this is because the start VR function in our VR pawn will not work inside of the engine, but only after packaging. Just be sure to delete it before packaging to make sure the starter pawn is always spawned at the start. Create that new BP_3D map blueprint, add a widget component, and set the widget class to W_top mode. You'll see that the text blocks all say text blocks, and this is because the pre-construct function inside of the buttons hasn't run yet. But that's okay. We know it works from seeing it inside of UMG. Change the draw size to 1920 by 1080. That's going to be a massive widget, but it will give it enough pixels to be high resolution. Now scale it down to a size that makes more sense. I've set it to 0.1, and when placed into a scene, the sizing looks good. Now we need to build the logic for spawning this map and manipulating it. Thinking back to the project goals, when both triggers are pressed on the motion controller, we will spawn the map. When one trigger is released, we will leave the spawned map where it is, and if the motion controllers are not too close to each other, it will stay visible. Let's start with two variables inside of our VR pawn. Both booleans, named left hand pressed and the other named right hand pressed. We'll set those after the pressed and released inputs. Then we'll add a branch right after asking if the opposite hand is pressed. If true, they are currently both pressed, and if false, only the current one is pressed. I've created a new function named spawnMap and an event named startMapTimer that will get called after the user has pressed and is holding both triggers. In the spawnMap function, let's spawn the 3D map to the transform of the VR root and promote it to a variable. When startMapTimer is called, we first want to check if our BP 3D map widget is valid because we only want to spawn it one time. If it's not valid, spawn the map, and if valid, continue. Create another function named adjustMapTransform. This is the function that will take control of the map, and every frame it will update its location to the midpoint of the two controllers and the rotation to always look at our HMD. Let's create our find midpoint as a macro. It's very easy to convert this equation to blueprints. It will need two vector inputs and one vector output. Split all of the structure pins. The equation is x1 plus x2, y1 plus y2, and z1 plus z2. Then divide each by 2 respectively. Plug in the x result into x, and so on. And that's it. Now we have a macro that will provide us the point directly in the middle of 2 points in 3D space. We're going to plug in our motion controller's world location from each hand into the x and y inputs, and plug the output into our new location on a set actor location and rotation node for our BP 3D map variable. For rotation, we'll use a find look at rotation. The new location as start and the camera world location as the target, and plug the Z rotation into the new rotation. This is all pretty messy, so I'll select all of this and collapse to a function named getTransformData for map, and I'll make it a pure function. Back to our startMapTimer event. We asked if BP 3D map was valid. If it is valid, we'll set timer by event. This will call an event and, if we wanted to, which we do, loop the call until paused. Drag off event and type create event. This will give us a list of all our events or functions we have built that can work with a timer. Select Adjust Map Transform and promote this timer to a variable named MapTransformTimer. so we can pause it when we need to. Plug in Start Map Timer into the True branch after we press the trigger. We need one more event to test this, and that is to pause this timer when we release the trigger. Name it Check Map Timer. After another check to make sure the map is valid, add a Pause Timer by Handle node and plug the Map Transform Timer in. Connect Check Map Timer into the Released Input event. Let's test. Okay, I have just left hand pressed and nothing. Now I have only the right hand pressed and nothing. Now I'll press both, and there we go. It spawned and moving as my hands move. If I let go of a trigger, it stays in place, and if I press the trigger again, I've regained control of it. Now we'll add in the logic to determine whether the map should be visible or not. When the motion controller spawns the map, it will first spawn it and then check if it's hidden. If it is hidden, unhide it. Next, after you let go of the trigger, we'll hide it if your hands are too close together. This will also be used to close the map quickly. To determine that, create a new macro called Find Distance. This macro will find the three-dimensional distance of two vectors being the world locations of our two hands. Same idea as before, but a different formula. We'll still split all the structure pins, but we will end with a single float value. To find the distance, the formula is x1 minus x2, and so on. Square the individual results, add them together, and take the square root. The provided float value is the distance. Play what feels right for you, but 25 seems like a good distance away to be too close for use. So if the distance is less than or equal to 25 when you release the trigger, hide it. If it's greater, keep it visible. Let's test this once more. Lastly, add a location offset in the BP 3D map. Create a scene component and place our navigation menu into it. Create a new function named setRelativeLocation on widgets that sets the relative location of the new scene component, which I have named scene_widgets. We only want it to affect the X location, so it will go only forward or backwards based on the distance of our motion controllers. Add a map range clamped to the distance input, plug distance into value, and set the in range to 0 and 200 and the out range to -300 and -10. Unreal Engine uses centimeters as its unit for length, so 200 centimeters or 2 meters would be a long but not abnormal arm range. And what we are saying with this mapped range node is that if our hands are at a distance of 0, send the map way back to -300 centimeters away, and the further our hands are apart, the closer the map will be to us. Think of it like pinching your smartphone with both your hands. Call this function in our adjust map transform function and provide the distance. And test. Much better. We have enabled spawning, resizing, and closing of the navigation map using the motion controllers. Next, we'll add the mechanics of interacting with the navigation map to set options and to teleport.